Okay, I'd like to welcome everybody to the SLT Millimeter Wave Learning Series, our free EMF educational series discussing 5G radiation and millimeter wave. Today's topics include the effects of EMF and millimeter waves presented by Lloyd, the effects of RF and millimeter wave sources presented by Magda. Then we have Rob and Bruce are going to introduce us to the millimeter wave meter and the difference of 5G frequencies and measurement protocols. And we have Keith, who's going to do new discoveries of millimeter wave sources. And then last but not least is Oram, and he will be doing the hunting millimeter wave towers in Southern California. So without any delay,
I think we should go to any questions we can. Any questions that are left in the forum or the chat?
Well,
we can answer?
There's 50 more that came on while I was doing my presentation, which I wasn't able to look at, of course. Now you can do what Lori's done. She raised her hands. So Lori, unmute yourself and go ahead and ask your question.
Hi, thank you. Yeah, I've been wondering if anyone has tested the inside of the car that has radar to see if its own radar is affecting the passengers or the driver inside the car.
When I was doing it, I did find some slight readings inside the vehicle. Yes. I'd say they were maybe 20%, 10% of what I was getting outside. Maybe even a little less, but I did pick something up inside the car.
Okay, thank you. That's what I wanted to know.
Thanks, Lori. Darlene, you're next.
Yeah, Oram.
Oh, yes, Tony.
I was just going to ask Rob, do you think that that was bleeding in from the outside, or do you think it's actually generating on the inside?
That's hard to say. That needs more testing. Yeah, I didn't focus on that this time, but maybe I could do some more testing on that.
Can I add something? I did just read in my Subaru manual something about the radar only operating when the car is moving over 6 miles per hour.
Right. See, that's a different transmitter, I believe. That's going to be coming out the front, and that's the adaptive cruise control. And that is going to be at the 76 gigahertz range, I think. So we don't have a meter to measure that at this point in time. And I've tried to measure it with the guys at the shop, and we actually, we had to accelerate to 30 kilometers an hour, and I had them standing in front of the car trying to measure, and we didn't pick anything up. So I'm assuming it's a 76 gigahertz radar signal coming out the front.
Okay, thank you.
You're welcome.
Does that answer your question, Darlene?
No, that was my question.
Okay, you good?
My question was about the protective clothing that you can buy. Are we making ourselves is there radiation being induced into the fabric? Is that a bad idea to wear those things?
Different types of fabric are made differently, and it all depends on the type of fabric that you have. But just the general rule of thumb, if you're wearing shielding clothing, you don't really want it to come in direct contact with your skin. For one thing, a lot of them have metallic coatings that can transfer off onto your skin. And another reason is if there's a field on these shielding fabrics and you're in contact with them, there's a very good chance that field can transfer over to you anyways. So we like to see different layers of protection. If you have a shielding fabric, you definitely want to insulate it from touching the body, from my point of view, and many electrically sensitive persons' points of view as well. So those are the kind of the caveats. And you just have to look at the shielding specifications for each material that you're using to see that it shields up to 40 gig and what the shielding effectiveness is of the materials at that frequency as well.
Sorry, I'm not understanding. Shielding.
Very blessed to be out here because it is a fairly EMF free zone, and part of the reason why we chose to live out here.
Sorry, go ahead, Darlene.
Sorry, the last part of that conversation was make sure it's 40. At
You're
least
cutting in and
40.
out. I'm sorry.
Oh, I didn't pick that up, Oram. Did you hear that?
Darlene, your audio is cutting in and out.
Oh, can you hear me now?
Yeah, try your last question again. Last part.
I missed part of the conversation where you said it has to be at least 40. 40 what? The shielding capability?
Rob, 40 meters, was it? Or-
Gigahertz. 40 gigahertz. Okay. And what kind of, are you saying like just wear a cotton shirt underneath, or do we need to wear something more than that so that the fabric doesn't touch the skin?
Yeah, if you want to just make sure you're isolated from that piece of shielding material somehow, you could try just a cotton t-shirt, but if it got sweaty or wet, that would get you in contact with the shielding material. So perhaps something a little that gets the material away from you a little bit more, something thicker, perhaps, maybe 1 or 2 layers.
Okay.
But yeah, then the number was 40 gigahertz. You want to check the shielding effectiveness of shielding material, at least to 24 or 30 gigahertz, because that's what we're measuring with the meter now, and what Oram's measuring with Verizon, but it could potentially be coming in at 39 gigahertz as well too. So, those are the 40 gigahertz is the important number there, I think.
Thank you.
You're welcome.
Thanks, Darlene. There was a question by someone. She says, do I understand well that it is not that we're not sure whether beamforming also takes place with a 5G enabled smartphone when the millimeter waves are not present? What I was talking about was the measuring that I was doing with the meter from my Verizon iPhone. I only got the 5G, 500,000 strong radio signal from this when the beamforming was going on. When I was in front of a Verizon millimeter wave antenna, that I could, and I knew that because I could see the activity on this, and the 5G, and especially the UW came on when I did something with data like speedtest.net, or downloaded something on the internet, or streaming audio or video. Then it would be very strong, but I don't know if that's beamformed. We don't know that from this meter. I'm going to ask that of the antenna manufacturers and the Verizon folks at the conference I'm going to go to. So that's as much as we know. Stephen Lawrence, you have your next. Go ahead and unmute yourself.
Yes.
Yeah, go ahead.
Can you hear me?
Yes, we can.
Okay. Yeah. It seems like we're going about trying to kind of reverse engineer some of this technology, and I was just curious if it's been done yet, where someone has gone through all the patents and tried to look up these technologies, and there's got to be patents out there for all of this, and try to understand through the patents how these technologies work.
Well, that's what I'm trying to do. And what you can all do, those of you who are inclined to do this, is attend these 5G conferences. There's a similar one, a much smaller one in Brooklyn that's held a 5G conference that I saw in a nice 5G write-up on the techwellness.com website from a colleague of mine, a client of mine and colleague here in Southern California, Bryce August. And she has a link to that. And so there's the Mobile World Congress Las Vegas conference in the 3rd week of September for 2.5 days that anyone can go to. It's open. There is a fee to get in, a couple $100. So then there are also webinars that you can watch for free from Rode and Schwartz, and then the Qualcomm and some of these other software companies and other companies, Fierce Wireless. I have those links in my 5G article at createhealthyhomes.com. Go to education and then 5G, and then scroll down. You'll see links to these resources from the industry itself, and they have webinars, and you just sign up, and 90% of it will go over your head, but you'll glean some of it. And I can follow it for the most part. You just have to know what the acronyms mean. And then you'll understand what's going on with the technology. Okay. So anyway, James Costa, you're next, but good point. Stephen. James, you're next. Go ahead and unmute. Yeah, there you are. Unmute yourself. And what's your question, sir?
Sorry about that. Thank you all. It's been a while. I got the opportunity and the pleasure to talk to you, Oram. Quite an extensive conversation we had a while back on your way to a job one time.
Okay, thanks, James.
So thank you for all the help. But and I had a couple things here, but I'm going to try to make it real quick to be respectful of time. First of all, I missed the first part of this. Is there going to be a replay of this recording?
Tony, you want to speak to that?
Yes, there will be a replay, and we will be sending out a link to everyone so they will have the opportunity to watch it from start to finish.
Awesome.
And also just make note, www.safelivingtechnologies.com. Then on their menu bar, you'll see education over on the right. And when you hover your mouse there, the drop-down menu will appear. mmWave, millimeter wave learning is the first entry. You click on that. That takes you to the page that you typed in your name and address to get the Zoom invitation for this conference. And Rob's going to show it to us. And then if you scroll down on that same page, you will see there will be links. There are links there to the previous two learning sessions, millimeter wave learning sessions. They're right there. You see where it says education, and there's the millimeter. Okay. Now, when you click on that, now this will be changed by Tony later today because this event, but there are the links for the previous, see in July, and then the one on June 28th. And then also you see there the download the, go up just a little bit, Rob. Yeah, download the slides and so on. So all of those links are there. And what the staff has done is to take, like, Rob's slides will be first, my slides will be right after them in one big PDF. Okay. So, but the link to the replay of this meeting will be right there within a day or so. Tony's going to put that together and his colleagues.
Beautiful. Beautiful. Thank you. Thank you for that. I haven't had a cell phone in over 25 years or Wi-Fi or any of that stuff. So I live in basically in a Faraday cage, 2,000 square foot Faraday cage. Got opportunity to spend about an hour with Dr. Martin Paul here in Bandon, Oregon a few years ago. And he gave me some good tips about the 5G, what he knew at that time. And I have, in back of me here, I have on the wall, this, I'm sure you folks, most of you are familiar with this radiant barrier. I used to sell this 30 years ago for insulation, and that's what it's in. This is my production room here. That's what it's in here for, is insulation. But Oram was talking about the holes, and Dr. Martin Paul did as well. He told me about the way to shield my skylights in here. And because of the millimeter wave is so small, you need a very, very fine mesh stainless screen screen. So I guess this radiant barrier is great insulation. It's amazing, but it's not really good from what I'm hearing Oram talk about and Dr. Paul. It's not really good for 5G because of the holes. There's holes every half inch in this insulation.
And James, when you say 5G, we all have to really specify. Are we talking about high band 5G, millimeter wave band, mid band, low band? The physics are different because of the wavelengths. Mm-hmm. The frequencies are different, and when the frequencies differ, the wavelengths differ. And when the wavelengths differ, the characteristics or what's possible for penetration, for distance, and for shielding, it's all different depending on what band. Yeah, so go ahead.
Got it. Yep. I got
James, it all depends on the size of the holes too. So
Yeah.
And the distance they're apart maybe. So now that we have the millimeter wave meter, like that would be a good thing to test with the meter as well. Just if you had a source,
Yeah.
stick it in between the source and the meter and see if there's any leakage through. Because aluminum foil, there should be nothing that comes through. It's almost 100% effective. Over 100 dB it should be. So
So when he
these
says 100 decibels of reduction, he means 99.99, many nines.
right, almost
right.
100% shielding. Yes.
Yep. Yeah, these holes are they're a pinhole. They're the size of about a straight pin.
You mean in the aluminum foil?
Yeah, and they're about every half inch. Every half inch sheet.
That's
Yep.
for air to get through. Those are very small, Rob. I know
They
what
are
he's
very small. Yeah, I don't know if you're going to see much of an issue with that, but yeah, it needs to be tested and seen. Yeah.
And I don't have a source here. Thank God. I live on 5 acres out in the middle of nowhere. So
you don't want to, no, you can't have any sources anywhere near where you live. So
no, I have a tenant next door with a router, but I don't see much of that in here inside.
no, you won't, because of reduction with distance and with the walls in between. So James, thank you very much. Nice to speak with you and hear from you again. So
Yeah. You know, one last quick question. I know you guys just put an awesome meter out right now, but I had the opportunity to check my old Pro with a friend's Pro 2 just the other day, and it was pretty amazing. You probably don't have any new meters on the market to cover. I mean, they all kind of need to be separate meters. I could see why. Because
they're designed to measure what we get, what we're exposed to in our homes and near our homes. So
Mhm.
cell frequencies are covered in the range that this covers, which is up to 8 gigahertz or so, and Wi-Fi, cell signals, and so on. Now, this came up in the chat, and I responded to it, an hour ago. Between 6 gigahertz or 8 gigahertz and 20 gigahertz, it's not empty. There's a lot of stuff out there. A lot, it's full. If you look at the representation that the FCC puts out, in any given area, mostly in urban areas, you'll see a lot of different things. But what it represents is police band, aviation, satellites, military, radar, and the transmitters are not anywhere near homes. Generally, they're on military bases, at airports, up in the space, et cetera. So by the time it gets over many miles to your house, it's very weak. So that's why we don't worry about it. So thank you very much, James.
Thank you, sir. Appreciate you very much.
You're welcome, sir. Nancy, you're next.
Hi, I've got questions for Rob.
Go ahead.
Rob, a couple questions on the car measurements that you did. What were the maximum levels that you got on the sensors? I couldn't see the meter.
Sure. Yeah. That's the difficulty. It's hard to videotape the LCD display on that meter. So, when I was near the bumper, it was around 30,000. I think the highest spot was about 100,000, but that was basically with the antenna right up against the side of the car. So it does decay quickly as you move away from it.
That was my other question. How about at 20 foot away, is it going to be gone?
It's going to be much less for sure. Like when Keith was measuring those cars drive by, I think he was getting readings in the tens or hundreds.
Yeah,
Yeah,
that's what I got in Santa Monica as well.
Somewhere in that range. So yeah, it's going to be significantly less.
And do you think that pretty much all of this radar is not going to be activated unless the car is going 6 miles per hour or more, or is that just for that one vehicle? Yeah,
you're probably not going to see the radar in the cities because you can't typically turn on your cruise control in a city. You're going to see more of that on the highways for sure.
But there's lane. I think it's some of it's on all the time, Rob, isn't it?
Yeah, there's collision detection systems in there, and I just don't know. Well, that sheet that I I looked up and found out all those transmitters and the frequencies that can help us analyze what frequencies are actually out there. But some of them, we don't have meters to measure, unfortunately. And if they're using higher frequency radar in the 76 gig range, then we're not
Yeah.
able to measure that, unfortunately. But that's not saying it's still not coming out of the vehicle at certain spots.
But it is directional and it's aimed outside away from the car. So you're going to be affected by cars that drive by you, not from your own when you're in the
True. Yeah.
driver's seat, right?
Yeah.
No, I can't drive anymore, but I'm concerned about the neighbors driving by me about 20 feet away on their
Absolutely.
driveway. And
Well-
I'm sitting outside right now and they're passing by. I'm wondering, they've got a new Toyota hybrid. And I'm wondering how much radar is coming at me in my 1 8x8 foot square foot area outside that I'm safe in. And I don't have that side shielded. So I don't have one of these millimeter wave, and it probably wouldn't pick up their radar anyway. So, and unfortunately, I found out in the last webinar that they have that they're shooting radar out the sides of the cars too, not just the front and the back. So, yeah.
Yeah, unfortunately, we don't have all of the equipment we need to completely assess that. But yeah, if there's a building biologist local to you, they will probably have a millimeter wave meter that they could come out and do a test for you. But unfortunately, you're only getting a piece of the picture. You're not getting the whole picture.
Well, I'm hundreds and hundreds of miles away from the nearest building biologist, but I have another question here. What material do you have, like this Swiss Shield fabric, that will shield up to the 400 gigahertz?
Well, the 40 gigahertz, the Swiss
Or
Shield.
40, I meant. Yeah, sorry.
Yeah, no problem. Yeah, the Swiss Shield Naturel will shield up to 40 gigahertz, and we have data on that. And it's still in the 90% shielding effectiveness, like, or 96%, I think, 95%, somewhere in there for Swiss Shield Naturel. And
Great.
so it does offer some protection. And the bonus with Swiss Shield fabrics is there's no exposed metals on it, like a lot of the other shielding fabrics out there. They have exposed metals, where Swiss Shield does not have exposed metals. And that's key for us and any chemically or electrically sensitive people.
Now, I've found that myself. In fact, when I was first starting to use some of the fabric years ago, I got some that had it painted on the outside, and I actually got an electric shock being too close to some electrical device, and it yeah, I connected with the silver painted on it, and I thought, this isn't the best fabric. So
Okay.
I love the Swiss Shield fabric, and I endorse that.
Okay, great. No, thanks, Nancy. Yeah,
Thank you.
We've seen that as well. Yeah.
Please keep testing these vehicles, and the total EV ones, I would really like to get more information for. And some of us who are doing submissions to the federal agencies here, we're trying to reply about transportation and vehicles and smart roads and all of that. So any information that we can get from you to add to our submissions, we would really appreciate it.
Okay, Nancy. Yes, we've got a lot of work to do with this millimeter wave stuff right now. It's just the
Thank you.
beginning. Yeah.
I know it. It's hard to keep up with what the industry is doing.
Yeah, no kidding. Oh, thanks for your comments.
Okay, thank you, Nancy. Elle, you're next.
Okay, hi. Thank you so much. I was at the last meeting. I have a quick question for Magda. I think she was on a little while ago. And then one question for you all at SLT and Oram. So the question for you, Magda, is as far as the 5mm system, or that's set up around that may be set up around homes. Others may know this answer too. The 5G ultraband system that may be, if not around the average home, but let's say in the city. is that I've heard a pulsing sound. I heard a pulsing sound for many, many months prior to anything else I experienced, coming from my neighbor's back, big yard area. And anyway, later soon thereafter, I had very high blood pressure, which was unusual. And I know nobody can diagnose or say it's exactly that, but is that possible? Is that one possible mechanism for a blood pressure change? Because I know that there's been science writings on how it can impact the heartbeat, or the pulse, pulsations from the 5G millimeter may impact.
Right, no, that's a great question, and yeah, Magda would be the best qualified to answer that one I'm not sure if she's still on the call.
She is, Rob. She's right.
Most of the research has looked at the effects of the radiation on heart rate variability rather than on blood pressure. And basically what it's showing is that some percentage of the population go into a fight or flight response. So they develop a stress response, which means their sympathetic nervous system is upregulated and their parasympathetic is downregulated. This is often accompanied by high blood pressure, but that's very individualistic. So the fact that you're experiencing high blood pressure, it could be from the radio frequency radiation, definitely.
Okay, thank you. And I know you have to always rule things out. And I appreciate though that it's there's been an association of that. Thank you so much. Okay, and then switching back on this whole thing of the 5G, and I appreciate the discussion, especially this time where we hear that in the cities, it may be where city residents need to be concerned about the 5G millimeter in their home inside. Because
absolutely, in apartments, buildings, and so on.
I'll ask this is an easy question. You were beginning to share about the types of mitigation or that you might do, and you said it has to be solid material, not so much like the fabrics. It needs to be something solid. Is that correct?
Oil and paint. But Rob, you want to?
Yeah, those are the most effective, and you'll get 99.99% shielding effectivity with those. Fabrics, it all depends how they're made. If they're basically a coated fabric, they may do not too bad. But the way then they have exposed metals. But the way Swiss Shield works, Swiss Shield is a mesh of wires as well, intercrossed horizontally and vertically. So there are small gaps, and that's why we don't see the 99.99. We still see 95% shielding from that though.
Okay, I have your materials. Now here, I may be this aberration. And so I'm glad though, Oram, you mentioned how it was very, very rare that you found high level, the 5G millimeter being an issue for homes. Okay, and
when I go into residential neighborhoods where 60-70% of my clients live, I don't measure anything.
Right. Anyway,
why? Because it costs money for these companies to put these antennas in place.
Right.
Not, just because they say they need them every third house to get the coverage everywhere doesn't mean they're going to do that everywhere. They're only going to do it where there's foot traffic.
Right. I appreciate it. And maybe I'll just follow up. I'd love to follow up because I'll just let you know my overarching statement is they're formally testing in my area. This is what I mentioned last time, per my whole local government. I know I'm seeing satellites now. I'll just leave it at that over my head, and I'm having symptoms. I have the new meter. It registers green with the stub antenna. I'm going to get the next antenna you guys mentioned.
You have this one as well, Elle?
Yes, I just got
both.
Oh no, I don't have. I have a safe and sound, but not the I have the safe and sound, and it reads green.
Well, Safe and Sound Pro or the Safe and Sound millimeter?
Oh no, I don't have the Safe and Sound millimeter.
You don't have the blue one?
I do have the blue one. I don't have the green one.
Okay, you're going to find a lot more activity with this.
Okay.
A lot more, because this is all the low and mid-band cell signals that we've had for years.
Okay, I'll get that.
The Wi-Fi. Oh yeah, no, this is like a third of the price of this one.
Well, I've got the other one.
Okay,
Thank you.
you need both, you know.
So- Okay.
Yes, ma'am. Okay, thank you.
What, just for other listeners too, what was that solid material you were referring to though, Oram, that might be helpful? I appreciate, and I do have some of the Safe and Sound products, even the foil.
Rob,
Yeah, that would be at the solid, the aluminum foil product, RF shielding foil.
Okay,
That is the best and most economical shielding material that I've seen.
okay, thank you. And thank you for another awesome session.
thank
You're
you.
welcome,
Thank you for attending. Okay, Elizabeth, you're next.
Yes, hello. Hi, I have a question just back to the cars again. Now, you know, a lot of the cars have the GPS built-in system. Is that using the same type of radar that you're talking about? Or I'm just wondering, what is a good way to, for example, if you're traveling, you need some form of a GPS. Is it better to try to use your cell, or is it better to use the built-in car GPS system?
Yeah, I would say like the built-in car GPS system, it's a receiver. It has an antenna on the roof that receives the satellite signals with the GPS coordinates and screens. It's at 1.5 gigahertz, I believe, and it's only a receiver. Now, if you used your phone, that's using the cell phone tower, so it's sending data over the air to the cell, back and forth to the cell phone tower. So you get more exposure with the using your cell phone for GPS as opposed to the built-in system in your vehicle.
Yeah. Is there any guideline for if you're trying to purchase a car? I mean, I imagine older models are better. They don't have as many gadgets, but do you guys have any guidelines about that, about purchasing a vehicle?
Oram, I'll let you go too, but I would just get the various meters available to test for electric, magnetic, and radio frequency waves. And unfortunately, they change so much.
Yeah.
And they're different almost every year. It's just so hard to know what to expect in a vehicle without actually doing the particular measurement on that particular vehicle.
Yeah.
I have an article on my website, createhealthyhomes.com, then click on education, which takes you to a separate section where all the articles are that I've written over the years. And then you'll find cars. I think it's all the way over on the right under all about EMFs. And then I think that's where the EMFs and cars article is. But the thing is, Rob Metzinger, Larry Gust, Mitch Marchand, myself, we teach our students in the building biology profession to, and Spark Burmester has been one of our teachers for decades. We teach students and our practitioners how to evaluate homes, buildings, and you know, so 120 volts here, 240 volts in Europe, and magnetic fields, electric fields, radio frequencies, and dirty electricity with the various meters that we use. And so we're pretty good at that, but cars have a completely different a nervous system, a completely different wiring. They're not 120 volts. There's DC, there's AC, 24 volts DC. There's 80 volts AC, but the voltages vary. Spark has taught me a lot about this over the decades. You can have you have AC wiring, which causes magnetic fields that we measure with our AC Gauss meters, and so you'll have that current going to the different loads, but the return is not a single wire that's in the same path as the hot wire, like a circuit in your wall, like you have here with this Romac with a hot here and the neutral here and the ground. They'll use the grounding system of the car, which is just all the metal of the chassis, as the return path back to the battery, or back to the alternator, I should say. You know, and so there's no cancellation of the magnetic fields. And then the alternator is a huge point source of magnetic fields that comes right through the firewall, because magnetic fields go through virtually everything. You can slide the G iron Armoflex, or that you carry, Rob, you know, it comes 25 inches wide, and then it's sold by the foot, like $50 a foot. You can slide that under the pedals and but I have no AC magnetic fields when I drive my Prius plug-in hybrid on battery, none. And then when the engine kicks on, that's when the magnetic field comes. And it's about a 1.5 milligauss. Now it's full of RF. You know, I've got all the radar that Rob talks about, you know, which I appreciate, but I'm not electrically sensitive, and I want those safety features, you know. And so for electrically sensitive clients that I have, they have older model cars that don't have the radar. They don't have sometimes you can turn off the Bluetooth and Wi-Fi. Sometimes you can't. Sometimes it says it's off, but the meter shows that it still is. I turn the car off and then it goes away. And then I called up, you know, I had a Volkswagen Passat, and the dealer said, well, we don't even, that's not us. That comes with the communication module that you selected and we slid in there. It's made in Kentucky and has nothing to do with Volkswagen. It's the communication that has all the CD and the radio and such. That comes with that. And so it's a daunting task.
It is. And also, I know in the global EMF project, Magda has worked on automobiles as well and has a protocol for measuring them. But I believe it's only for the RF section. I don't think we're doing magnetic and electric for the vehicles at this point. So it's pretty tough to find a database with all that information in it.
Yeah. So anyway.
Would you say in general for EMF sensitives that electric cars are just no good?
No, not necessarily. I'm telling you, if you're looking at magnetic field, AC magnetic fields, they're much, AC magnetic fields in the driver's compartment are much higher generally from gasoline powered cars that we've all driven for decades, from the alternator and from this lack of cancellation of current running on the wiring right on the other side of the firewall, than in battery cars. Full battery cars, full electric cars run on 24 volts DC. There's no alternator. There's no gasoline engine. It's just 24 volts DC. You won't pick up anything with your AC Gauss meter. How many of you have a DC Gauss meter? Because that's what you're measuring. You see, 24 volts DC electricity produces DC magnetic fields. We don't pick that up with an AC Gauss meter. And the assumption that batteries must have all these EMF, I don't understand it. It's counterintuitive. At least the AC Gauss meters that we use, I don't pick up anything. When I'm on pure battery for the first 35 miles after a charge overnight in my Prius plug-in prime hybrid, zero magnetic fields on my NFA 1000.
Interesting. Interesting.
Yeah.
Well, thank you very much.
You know, can I just pipe in real quick ahead of this other person in response to what Elizabeth was talking about? I don't know this for sure, but I heard that the Teslas are one of the only ones, because I had
very low.
My
They're very
girlfriend,
low, James. And the Tesla dealer in Santa Monica said, we know about EMFs. And we actually, and he was right. I've ridden in 4 Teslas from my clients as we're driving, and I didn't pick up any. Now this is all I measured was AC magnetic fields. They're
Right.
full of RF.
right?
They're
Yeah,
full of RF. So, but the thing that most electrically sensitive people react to is the varying voltages. So it's the dirty electricity. Spark help me understand this. That's what most EHS people react to. Like in a Prius with the regenerative braking, drives them crazy. They cannot be in a hybrid car for that reason.
I didn't know that long time. I didn't realize that. I'm pretty sensitive myself, and it took me a while to figure it all out with the Prius, because we got the first Priuses that came out, 20 plus years ago. So anyway,
Right. Yeah, thanks, James. Magda, you had a comment?
Yeah, I was just going to say we've measured hybrid cars and they do have a high magnetic field right near the battery, which is often in the back seat, which is where you would put an infant.
So are you measuring with an AC Gauss meter?
Yep.
Oh, so the engineers among us, help us understand, where does that come from with DC 24 volt DC current? Where's the AC magnetic field?
Well, it's a hybrid car, so it has alternating current too.
Oh, that's right. It has a gas engine as well. Yeah.
Yeah.
Okay. That's true. It's a hybrid. It's not a
Yeah.
pure electric. Okay, got it. Thank you for that comment. TH, and Joan, we're getting to you. I know you said in the chat, I'm just going through. Okay, TH is up next. It's just whoever put
guys.
their.
Hi guys. I've purchased a good number of meters and shielding from Safe Living over the years. And my question is to Rob regarding the attenuation rating for all the shielding material. Was that done in-house by your company? And if so, can I ask what the source power density levels were that you used to create the ratings?
The ones we have on our website are from the manufacturers at this point. I think some of our materials are only evaluated up to 18 gigahertz. I'd have to go through them all and see which ones we did and which ones we
No,
didn't.
I didn't mean the frequency range. I meant the power densities specifically in the mid-band range for the material. Like I'm saying, what was, did you just use a cell phone behind the?
Oh, no, they're done in, most of them are done in testing labs, and they use signal generators.
Do you know
and
how high the
amplifiers.
power densities that they actually test at?
I might have to go through and read through the studies, but it would be probably in the range of probably above 1,000 microwatts per square meter. I'm not sure exactly what levels they were tested at.
Do you know either from experience or from the manufacturers whether the shielding effectiveness changes or the dB rating curve changes depending on the power density levels?
For shielding material, usually no, but for measuring devices, there's a potential for that to change.
Mm-hmm. Well, I'm in an unfortunate position where I'm in the process of shielding my girlfriend's apartment in New York City, and they installed a cell tower 20 feet from her front door facing her apartment.
Mm-hmm.
And luckily they haven't turned it on yet. They've tested it, but they're not turning on until October. And this is with Dish Network. They're apparently turning on thousands of new installations in October.
Mm-hmm.
And
Dish is using pure 5G technology from the ground up, by the way. They have no 4G customers like the other three companies do. So they're all using standalone.
It's the company is JMA Wireless. Their website says they're the leading 5G technology in New York City. I've taken pictures of the actual installation on her rooftop. It has the actual frequency range. It's low band and mid band.
That makes sense.
Yeah.
Wait, low mid is what again? Say it again.
Well, I have to look at the picture, but it's approximately mid 600 to 800 megahertz, and then and it also has 1.8 gigahertz to 2.4-ish gigahertz, 2.3-ish.
That's low band, and then the lower part of the mid band. They don't beamform below 2 gigahertz, from what I was told at the 5G conference.
Oh yeah, 20 feet, you're going to get a significant level coming off of there.
Blasted.
So then the way you got to look at that is if there's 1,000 microwatts per square meter hitting you, or 100,000, the shielding is going to perform the same. It's going to be, it's going to offer you a dB level in shielding, and that's going to be 99.9 something percent
without reflections.
Right. That's in theory in a lab.
It's only
with one source.
I'm not concerned about shielding for just even 500,000 microwatts. I measured on her rooftop, and this is another point. The towers aren't on yet, but across the street, about 80 feet away, on the rooftop of the next building, they have mid-band towers that were installed during COVID, and on my Safe and Sound Pro, and I own 2 of them, and my girlfriend just bought another. I measured on it 3.18 million microwatts, which I know is above what it's
where in her across the way in her apartment, or
no on the rooftop, in open air, open view site of the cell tower across the street, which is about 80 feet away. So I guess that and my concern is also that the phased array beamforming technology is not exclusive to 5G, and maybe it could be called 5G, but I am certain it has been installed in old 4G technologies as well.
There's a lot to unpack in what you just said. That's what I'm learning. That's why I'm going to these meetings to learn all of that.
Right,
Those
well, I mean,
details.
or I
TH.
mean, these are industry meetings that you're going to, correct? And,
Yeah.
and you did mention last time before that they told you before that the mmWaves would never pass through anything, and obviously you learned that that's not true.
No.
They pass through glass and fabric.
They
and all
didn't
that.
quit. No, their expectation, and it doesn't pass through walls, even just
Well, yeah,
regular.
I know that.
Oh, we lost you. Are you still there? Oops. Oh, TH, you still there?
Yes, I'm here.
Okay, you dropped out in the last 20 seconds. You're coming and going. Okay, Terry, let's go to you next.
Okay, hi everyone. Great to see you. Thank you for being such great teachers. So got a little conundrum for us city dwellers. And TH, I just want to say it's possible to shield apartments very nicely.
Oh, Terry, you're in Manhattan. I didn't
Right, but
recognize you. Yes.
Right.
one of our-
It's been 11 years since the training with everyone in Evanston. So great to see everyone. But TH, I want to say it's possible in New York City to shield your living space. You have to be extremely diligent. I've had a lot of help from Oram and Rob and the whole team. You can live safely in New York, but it's, in your apartment, but it's a great deal of work. It is possible. So the conundrum I'm having is with everything going on with driving, and how we live in the city, I was following Dr. Klinghart's advice to wear the shielding clothing, which I've been wearing when I drive and when I go out and about, but I'm hearing Rob say that that's not a great idea because a lot of the shielding clothing, which comes from a different company, it sounds like what's being said is that on some level, the shielding clothing is transmitting frequency by touching our skin.
No, it doesn't transmit a frequency, but it allows it to pass through. There is some attenuation. It's just not, but it's not as much attenuation as it was in the old days with the lower frequencies with the longer wavelengths, so remember, it depends on frequency / wavelength and power density and distance.
Right. So those of us that know a lot, we have a lot of information with which to be scared and freaked out and immobilized.
Or to not be scared and freaked out.
Right. So I'm very grateful that Lloyd is doing this documentary because he'll cover things like earthing and PEMF and taking salt baths. And
EMFs, by the way, have very high electric fields if they're not grounded. That's a real problem with those things. Anyway.
Right. So coming back to my question is, how can those of us that live in cities, I've been wearing shielding clothing whenever I walk around and whenever I drive, and now I'm hearing that it's really not a good thing to be wearing. So
Terry, I think it's more individual too, like different people react differently to it. And some people are compatible with one and not the other. So it's kind of, you almost got to treat it as a little experiment and
see what works for you.
Try them and see what works for you, basically. Yes.
I'm not electrosensitive. I just know too much.
Well, you're very concerned about it. I mean, you've been dialoguing with me for a decade and because of your concern, and that's good for you. You're paying attention to this for your health.
Well, please let me interrupt. But
there you are. Go ahead.
Yeah, but I've built many more Faraday spaces and rooms than I ever wanted to in my life. Maybe 8 or 9 so far, and I learned from Jack Cruz. I don't know if you're familiar with him, but he's basically has been telling everyone that the mmWave spectrum will jump conduct onto any metal, including 5G clothing that has the silver on the inside and cotton on the outside. And from my own personal experience, even before I got the mmWave meter from you guys when it came out a little over a month ago, I was wearing the Get Lambs clothing for a week in New York City, and my Bristol chart was totally destroyed that entire week while I was doing everything correctly. And when I stopped wearing the clothing, just by coincidence, after the fact, I realized that my Bristol went back to normal. You guys have heard of they have wireless cell phones now that are charged wirelessly by I believe it's jump conduction, where the electricity is passing through the air. Well, that's exactly what's happening. It's using millimeter waves, correct?
Not sure, but it has to do with proximity. Don't forget that.
Right, but any jump conduction of millimeter waves onto the body,
Yes, if the source is close enough to you.
Right. Well, I mean, even if it's 100 microwatts, which to me, with millimeter waves is unacceptable.
Correct.
I think any exposure to mmWaves is unacceptable.
But TH, if you live in Manhattan, you're in the hot seat.
Oh, I know. I split my time with California. Here right now, I'm in a small town, Northern California.
And you don't have millimeter wave transmitters.
Yes, I know that. I mean, I do at the grocery store. I posted a picture earlier.
Well, that's different. Yes,
right,
but not cell signals. And why? Because Verizon. Why would they do that? There's no outdoor foot traffic. That's where they put these things.
Yeah, well, yeah. I'm not. I mean, yeah.
They'll do low band and mid band. By the way, I just read this morning that the satellite companies that were trying to give back their spectrum to finish the deployment of the mid band signals or frequencies in markets that Verizon and to a lesser extent AT&T bought 2 years ago, were able to transition out of those frequencies early rather than December of this year. They're doing it now, so they're completed. So the FCC has said to Verizon, you can turn on all of your C-band, all the rest of your C-band that you were waiting to do in December, you can do it now in August. So the full array of C-band is going to be operational in a matter of weeks for the Verizon and AT&T companies. So the mid-band is the sweet spot for these cell companies because the frequencies are the wavelength is of a
right. They pass through everything. Yes.
That they can pass through everything, that they can go for a few miles. It's not like the low band, but the download speeds are like 10 times, 280, 250 megabits per second instead of 12 to 48 for that 4G that we're all used to. So
do you guys know how I could have measured 3.18 million microwatts on the Safe and Sound Pro 2? And I've not only have I measured that, I hate to admit, but from a cell phone, I've measured 7 million microwatts on the Safe and Sound Pro 2, which I know isn't supposed to go over 2.5 million.
You'd have to be really close to a transmitter to get 3 million.
I was 80 feet away from the cell tower.
Rob?
And in direct line of sight, and there's probably multiple transmitters as well, I would imagine.
Right. Well, but I also measured 7 million microwatts.
That doesn't make sense because
no. 2 inches from my cell phone.
But
and I have
meter, the meter maxes out. The early ones maxed out at 2.5 million, and the future ones, after the first 4 or 5 batches, we got it up to 3.1 million, somewhere in that range. So
you won't see a number higher than that.
No, exactly. I wouldn't expect to see a 7 million.
I was shocked to see it myself as well. And I own 2, and my girlfriend just bought another. But okay. I mean, hopefully it's just an error. But I am concerned about phase array beamforming with the mid-band 4G, 5G. That's an issue for people that are in the cities.
Okay, so TH, let's get back to Terry. She's waving.
She got cut off. Yeah.
Thank you, TH.
Thanks for your help.
Thank you. Go ahead, Terry. You're muted.
Last question, very generally. I understand I'm getting that car shielding is very, finicky and different for every car model. My question would be is if we decide to put some of the film over the car windows, if we have old cars, can the film be by the radiators in the windows, or that we can't use the film for that reason? And would it sort of generally add some protection if we don't use the radiator, on the rear windows? If there's a simple answer, and that's my last question. Thank you.
So you're meaning the defoggers, like those the wires that are embedded in the glass?
Yes. Does that affect the window film?
It won't damage the window film. No, it can take the heat. That should be fine. And then your other question was in regards to, will the electric fields couple onto it and transfer off? Is that what
No, I didn't. I'm just trying to very generally understand if I should consider shielding my car windows with the
Signal protect clear, yeah, you just want to make sure you have no transmitters on the inside. And that's part of the challenge, because you're not able to turn off some of those transmitters in some vehicles as well.
Okay, so that circles back to my original question. We're out in the world with a lot of things that are scary, that are beyond our control. So I understand we take care of ourselves, we live without these devices. But again, your feeling generally is that it's the choice to wear protective clothing or shield yourself is individual. And but when you go to the center of Toronto, or Oram goes to downtown LA, you just don't worry about it. Because
exactly, yeah, exactly. Like I don't think I'm electrically sensitive. I think I'm electrically aware. There's
Right.
feelings that I get
Good way of putting it, Rob. Yeah.
when I'm exposed that I know I've been in a high exposure environment. And, I realize that during the day traveling around, I'm not going to be able to block everything. But when I get home, rest assured, everything is completely under control here. And fortunately, my body is able to recover when I'm in my, I guess, RF sanctuary at home in the country, and my body can repair from the day's damage that I've absorbed or taken on in the big cities. And I think for most of us, I think that's about as good as we can get. Or you experiment with some shielding clothing and see if it works for you.
okay, thank you all very much. Appreciate it.
Thank you
Welcome,
very
Terry.
much, Terry. Rory, you're next. Go ahead and unmute yourself, Rory, and ask your question.
You there?
Yes, we can hear you now.
Okay. So my question is regarding a lot of times in commercial buildings, they put the equipment rooms where the transmitter is, all the data cable comes into the transmitters, which goes up to the antennas. And
Right.
so I'm just wondering, everybody's had any experience, and it's kind of ironic too, because this is in a medical building, a cancer treatment building. And I got to determine, is there a lot of magnetic fields, RF fields? Is there a lot of bleeding coming out of those rooms from the transmitters?
The transmitters are not where the radios are. Sometimes they're built in together, but they could be like 10, 15 feet from each other, but it just,
Yeah,
it's a
the
transmitter.
room is separate. It's Verizon, and it says keep back, danger, RF, and that's where they have, I guess they bring all their data cables in, connect that, and then that goes up to the antenna on the roof, right?
Yeah, those cables are using to carry the signal from the base of the tower all the way up. Depending on the frequency, they could be cables or they could be something called waveguides, which is basically a hollow pipe that high frequency RF signals need to transmit on or transmit through, because they don't carry well on wires. So they put them in these waveguides, these tubes that carry the gigahertz signals up to the tower and then transmit out of that. But each of those cables should be shielded very well. And I don't see a lot of emissions coming off the cables themselves, but transmitting RF requires a lot of power too. So there's going to be some huge transformer usually at the base of a tower or somewhere on a roof nearby a tower that you're going to get a large magnetic field from, probably. It could be electric too, but primarily a magnetic field because of all the power that those towers and transmitters are using. So that's where that would come into play. Maybe the power feed lines you would read high magnetic fields off of, but I wouldn't expect it to be on the data cables.
Okay, so that room, if they were to build, they want to build another room right next to that Verizon room where the transformers are. I know it drops off, magnetic fields will drop off. But I'm just
I wouldn't
wondering.
want to live beside that.
No, you said the magic word. You said the transmitters.
Right.
So you're up on the roof now?
No, so the antenna on the roof, but then it goes down to this room that they have.
But wait. The antennas are the transmitters. They're one and the same.
Right, so what's in that room? That's where
The
the
radio, the
the
radio.
radio, the
Yeah.
data cables come in from, that they connect to for phones.
Well,
Like the backhaul systems, and
backhaul system.
fiber optic cables that come
Right.
in and, transfer data from one point of the country to another point and rebroadcast it out into the air, local to that particular cell phone it's trying to talk to, right?
See, there's a whole backhaul network that people are not aware of. A client thought that when she's in Los Angeles and talking to her sister in Seattle, that when she's on Verizon, she thought that the call went from her phone to the Verizon tower that was closest to where she was. And then it
Right.
went from Verizon tower to Verizon tower to Verizon tower up the California coast, all the way up to Seattle, and then off to her sister. I said, no. It would be completely distorted and wouldn't work.
Yeah. Yeah, right.
There's a backhaul network that uses fiber optic. It uses mostly satellite, and then microwave towers that are point to point and like 10 miles apart, around the curve of the earth.
Mhm.
That's how it goes from city to city.
Sure. And that's what's in
Over
that
the-
room.
So,
That's-
Rory Ward up in San Francisco, I recognize. I'm sorry, say that last comment again.
Well, that's what's in that room, all that, like you just explained, all the fiber and.
Well,
See,
no, you see,
that's the friendly way to send data. The unfriendly way is when it hits those transmitters and scatters through the air, right?
right. That's where the RF is. And you don't
Yeah.
want to be behind them. You don't want to be under them or near them at all. It's, people these workers pass out if they get right in front of them. Chuck Keen tells stories about that.
Yeah. Was that room dangerous? Because it says keep back and it does say danger.
Well, it's just hard to know what else is in there, Rory. And is it danger? It said is RF danger.
Yeah.
Yeah.
Rory, you sent an email and I'm sorry I haven't gotten back to you. You sent it 10 days ago. And so where is this? So there's a room in the building, but then
Yeah.
the transmitter is up on the roof. Is that
Okay,
right?
Yeah, so I haven't been there because they're waiting to approve this, but they want to build a cancer treatment. There's a machine that they want to put in a room right next to this Verizon room.
Where
they
where the radios are.
Yeah,
Okay. Now, before you go any further about and Rob just talked about, the magnetic fields that would come,
Yeah.
there's no radio signals coming from the radio.
okay,
There's cables then, and Peter Sir can talk to this too. There's cables up to the transmitters, which are above, they're on the outside of a room.
right,
There could be a parapet, but and there's always a plastic rain cover, but the transmitters will be at the edge of the roof or because it needs to get out to the horizon.
So
So
it's
it
not like
goes
a ham
out-
radio. A ham radio, you have the transmitter and the radio in front of you, and then it goes up, sends it up to the antenna on the roof.
Yeah, but the transmission doesn't happen from the radio. It happens from the transmitter on the roof.
Okay,
That's
Yeah,
where the
there's-
RF is.
okay, so they're
But-
just powering
but-
and bringing the back end in, like
but-
you're saying, the data
but-
cable.
So say it again.
So just the fiber optics and the data cables are coming into that room, and that's what's powering the antennas, but it's not the signal. Transmitters are on the roof with the antennas.
Well, it's pairing it, but it's also providing the data, the information that's being transmitted. But I'm telling you, Rob and I and Peter and others are telling you that the RF signal that goes out at the signal to the customers out there, on the street and for a mile or a mile and a half, 2 miles, you don't want to be behind that or below it. I mean, we've all gone in, Rob and Peter and I have gone into buildings where we've had clients in offices and apartments in the floor right below the transmitters and behind
Okay.
them. Or worse yet, in front of them, where like you can have a building with a top floor here, and then there's another where the elevator is, and that's where the antennas were set back, and then the signal goes out and down, and it goes into occupied space on that top floor, and you don't want to be anywhere near that, Rory, including
understand.
behind it,
Yeah.
because you could get tens of thousands, hundreds of thousands of microwatts on a steady basis. 4G, like it's always on, and you don't want to sleep there, you don't want to sit there. So it's a no-go you're nowhere near 10 to 100 microwatts for healthy people. And an EHS person, they can't tolerate 10 microwatts.
Okay. Yeah.
You'll be nowhere near that. And so for a cancer, you need to inform them that RF is carcinogenic.
I know, it's ironic. Okay, well, I'll locate those and be aware of that, but then I just like do a magnetic test around the room just to make sure there's nothing.
Yeah, but my first inclination would be, what does your RF? So, if you got out a standard, we're not dealing with millimeter waves now, generally. We're talking about the 4G there. And it could be, when I say 4G, I mean low band, mid band, and I mean whatever 5G might be added to that. But to me, that's just souped up 4G. It is more biologically active. It's a little faster. It's much more modulated. But they even, remember I showed you that graph where 3/4 or 80% of the data traffic is still to this day 4G. But it's now advanced 4G. It's more modulated, and it's causing more biological effects. Electrically sensitive people are saying, I could walk in my neighborhood, even though there was a 4G tower there for 10 years. But now the Verizon truck came along and they made a change. It's not millimeter wave, it's C-band or something. And now I can't be there. Or they upgraded the 4G. There's no 5G, it's just 4G, but they upgraded it. And now I can't walk there. I'm feeling worse. So there is a biological effect. Anyway, we got to move on. So
thank you. All right.
Thank you, sir. Nice to hear from you.
You too.
Kay, you're up next. You want to unmute yourself and ask your question? Are you there, Kay?
Am I next?
Well, there's someone who's just Kay. All right. Well, let's go to Lori. Lori, you're next.
Hi, I think I just got my answer. I asked if you had the RF shield on the windows, the signal protect, and you needed to use your cell phone, would you be getting more exposed? And Tyler said potentially yes, which makes sense. So I know I want to protect from the outside radar, but I also occasionally need to use my cell phone, or someone else in my car might be using it inside. So I don't know if getting the film would make sense.
Rob, you want to speak to that? And you're muted.
Sorry, I'm muted here and I was just away from my desk for a second. I missed the first part of that question.
Oh, if I have the signal protect clear film to protect from outside radar, and I occasionally might need to use my cell phone for GPS to download the directions, which I then put on airplane mode actually, or someone else in my car is using a cell phone, we're going to get exposed more because we have the film on the windows, right?
Yeah, it will increase. There'll be more reflections. The chassis is all metal in most vehicles, so there's reflection off the chassis too. So yeah, using a wireless transmitter inside a shielded area is not the greatest idea, but it's all you know what, it's hard to know what's right, and it all comes down to trade-offs. It depends on the area you're traveling through. If you're getting blasted with RF continually, maybe it's worth it, and you are going to get elevated exposure if you use it from time to time inside the car. But what's the net result? In an hour's time, are you better off or are you worse off? And that's like data logging over long periods of time and figuring out what's better or what's worse. They're both negatives, but which is the worst negative? I guess that's the kind of the way you got to look at it. So hard to say exactly, because each area and each circumstance is different.
Yeah, makes sense. Thank you.
Thank you, Lori. Folks, it's 3 hours and 40 minutes. Let's just take 2 more questions from Nancy and Rita, and then also Simona, who I don't know how to raise. Anyway, and then we'll call it a day. Tony, and Rob, is that agreeable to you guys?
Sounds good.
Okay. So Rita, Betty, Rita.
Nancy.
Well, Betty, you snuck in there. We can't take any more questions.
Oh, it's Rita
Mine's pretty
Widman.
quick. Mine's pretty quick.
Okay. Just very quick. But no more questions after Nancy, Rita, Betty, and Simona. Nancy, you've been up
Okay.
before, but
Thank you.
make it
Thank
quick,
you.
please.
Yeah, well, my friend and my EMS friend Deborah just arrived here, and she sent Rob a message, a question earlier. She's been, she gets 0.1 gigabit of internet upload and download with CenturyLink. And they charge her for high speed. We are trying to, she has to use a cell phone in order to get on the internet and to do any Zooms or anything else. And we're trying to find a way for her to get some safe internet. And her question to Rob today is and to anyone else that's hosting is there a satellite option, or is there a dish option that she could put far away on her property and run a cable to her house?
Starlink is the only one that comes to mind at this point.
Well, also the in-town wireless internet.
LTE in town.
Well, there are companies out in rural areas, Rob, that that advertise a connection, and you put an antenna on a pole at the perimeter of your property or even on the side of your house, and then that sends signals to the town and receives very weak signals that are there anyway, that come from a transmitter on a mountain or in town, and then there's a cable, coaxial cable from that antenna that then brings it into their modem and their router, and then disseminates it through typical Wi-Fi. But you can turn that off, and you can plug in Ethernet cables and be hardwired that way. So there are people who I've worked with, electrically sensitive people, who have this arrangement, and the antenna, the antenna that transmits the signal back is on the edge of their property on a pole. And then there's
it's a directional antenna that
it's a parabolic antenna and
transmit behind it, yes.
And a cable
about how far from her house would she need to have that?
That's where it gets into an individual thing, depending on how sensitive a person is, Nancy. There's no cut and dry. If I said 100 feet, someone's going to say, well, that's not enough for me.
200 feet?
As far as possible, yeah.
100 feet. So
No, I'm making that up. I'm just saying we can't give a number. And plus there's a certain distance that the company, they'll say, all right, we'll go out so many feet, and then we'll put our pole out there. You got to talk to what's technically feasible, because they have to dig a little trench and put the.
And you want it elevated too, like elevation will help as well as distance. Yeah.
She's got a barn that they might be able to put it on.
Put it on the barn. But it has to face in the direction of their transmitter.
Right.
And you
the
just
transmitter and receive.
You just don't want to be between the transmitter and the tower. Yeah.
Perfect. Yeah.
And then it's just a matter of what they can tolerate. So is that good, Nancy?
Is that good, Deborah?
It's confusing to me, but I'll.
She may contact you again, Robin.
Sure.
If she needs more, but
sure, yeah, it's a 4G LTE internet connection basically, and it's an antenna that points to a tower, and there's a cable that comes inside and brings your internet inside. And if it's at a distance, you should be okay with it.
Well, anything is better than her having to use her cell phone, which
of course,
really
right.
sick.
Of course.
And she's already gotten a sort of a resurgence of the EMS, and we really need to get her connected to internet that will actually work safely.
Where does she live?
We're in Southwest Colorado. Southwest Colorado has very little high speed internet.
Okay. I say that because there are building biologists in Boulder, several of them. I know that's.
We've had Ryan here.
Okay.
But it's a trek for him.
I know. It's many hours. I know. Thank you, ladies.
We appreciate this. Thank you.
You're welcome. Rita.
Yes, thank you. The other day was in the backyard. We have underground cables and metal boxes in our yard. I was raking. I started coughing and throwing up, and it lasted, I had to run away from the area. So is this what's happened with the upgrade in or including 4G?
We don't know,
I never
Rita.
had that happen.
Yeah, okay. People call, I'm sure they call Rob, they call me all the time, and they immediately jump to the conclusion. It's got to be 5G. We
Yeah.
don't know that for sure. It could be magnetic fields, could be electric fields, could be an RF source right near them, could be dirty electricity. Where do you live, Rita?
I live in Colorado, Littleton, Colorado.
Littleton.
Yes.
You're closer
I've
to
had Ryan. Yeah.
All
Leslie,
right.
excuse me. I have had him to a downtown Denver home, and he did an excellent job helping us there. And our son had to sell that property.
But how far are you
because-
from Boulder and Littleton? You're
Oh
close.
yeah, no, I could call Ryan. Yeah.
He's a half an hour away.
Well, yeah, I just saw that this was available, and it was so shocking that just happened that I've never had that happen since I've lived here. So something's changed in the backyard.
Okay, all right. Whenever anyone calls me
Oh.
with a set of symptoms like that, the question to us that I need to know data. What are the what
I
what
see.
what does a meter read on your
Right.
property?
Well,
That's how I can help
Yeah.
a person.
Very
And I will
good.
only come to a conclusion once I have data.
And I respect that. Thank you. I apologize. I don't have the data. I did have
No,
I'll get in touch with Ryan.
you need to
Thank
have
you.
someone you come
Yeah.
and do that for
I
you.
agree.
Okay.
Thank you so much.
Thank you. Betty.
See, did I get unmuted?
Yes, we
We
can
hear
hear
you,
you now.
Betty, yes.
Okay, good. I am fairly electromagnetically hypersensitive. I have people come visit me in my home or get into my car with a cell phone. I have a metal box in my house that I've had somebody test by putting a cell phone in it and using a meter to see that the metal box does actually block the field. But I'm very uncomfortable with some people that don't know how to turn their cell phone off. And one of my questions would be, how do I tell somebody to turn their phone off if I'm worried about all fields that it could radiate? Do I tell them to put it on airplane mode, or did I tell them to turn it all the way off? That's my first question. Second question is there something else that's lighter than this metal box that I've got? Is there a cloth or some kind of a pouch or something that I can carry with me in my car? Somebody jumps in my car, they don't know how to turn anything off, and it's quicker to just throw this phone in a bag or cover it with a cloth to get me away from all fields, is my second question.
All right, I'll take part of it. The bags to put them in. A metal box is the best because it's solid metal. So if you're going to do something like that, you can almost just even take a piece of aluminum foil from your kitchen and, wrap a phone in that, and that'll do a very effective job in blocking radiation that we're concerned about. Or there's other boxes and metal devices out there that you can purchase, I think, from other companies out there as well. They're available, and you want ones with the highest shielding power. So that usually means solid metal. Like there's some made out of mesh, which I'd recommend more of a solid metal, like a steel box or an aluminum box, or wrapping the phone with solid aluminum foil. So that's what you could do with the phones. I'm going to let Oram take the first part of that question or add on to this with the airplane mode on a phone.
So I'll start with iPhones. When you put it in airplane mode, it's still possible for the Bluetooth and Wi-Fi to be on, or in what's called not connected mode. And there are two ways to turn Wi-Fi and Bluetooth off and go into airplane mode on an iPhone. One is to just sweep down from depending on your model, one of the corners, like on my iPhone here, I'll sweep down from the corner here. And then it looks like that. Now, if I'm in airplane mode because I didn't want to be disturbed, but if I come out of airplane mode and if I have Wi-Fi and Bluetooth on and I turn the Bluetooth off, it goes white. And people think that that's off. Now, what I'm going to do now is to go in here and I'm going to go to settings and I'm going to show you what, and lo and behold, does not say OFF. It says not connected. Not the same thing. It's still looking for a signal. Okay. Even if you don't have Bluetooth or Wi-Fi, like a router with Wi-Fi on in the house. So you have to go into settings when you're not in airplane mode to actually turn off. So I have to go to Wi-Fi here and then turn that off. And then I go back and now I'm going to go back here and now, sorry, now it's not white anymore. It's gray or transparent with a diagonal line through it. And if I go to settings, it says OFF, not connected. I have an article on my website, createhealthyhomes.com. Click on education. In the welcome page, you have articles there that I featured, safer use of cell phones. And that's where this information is located for iPhones, and then Android is there as well. So that's where you can get that information all laid out for you. So,
it's a challenging feat to do that, really. So, if you were to just, the simplest thing would be just to turn it off. If you turn it off, you're going to be good. But yeah, there's all these caveats to, what is airplane mode, because now they allow Wi-Fi in airplanes too. So it's complicated, and you don't want to, having to navigate through Android and iPhones and know where all the spots are to click. It's challenging. So turning it off may be the best idea, or putting it in a shielded compartment. That's a good idea. Or, if you do try to adjust the settings, if you have an RF meter, you can detect whether or not you did the correct job or not by turning off all the transmitters.
Does that answer your question, Betty?
Yes, thank you. So I have some aluminum foil that's like a really thick model of aluminum foil. So I could just make some sort of a little bag and line it with all this heavy foil, right?
Less EMF has those as well.
Uh-huh. Okay.
Yeah, you just don't want any openings, right? It's got to be completely sealed. Yeah.
Right. Okay.
They have a metal, a cylindrical metal thing with a top on it. A client of mine had a coffee can or something, or a cookie tin, and it was remarkably effective at blocking the RF signal that I measured, with this. So
Okay. Is it true that somebody using a cell phone can have it off, but they're hunting their calendar or something like that? Does that still have some kind of a electric field or magnetic field or something that can be affecting me?
Yeah, that's a 20-minute answer, Betty. Yeah. There's so much to do with cell phones nowadays with magnetic, electric fields, RF, the wireless things.
People will tell me, "Oh, I've got it off, but I'm just looking at my calendar. I'm just getting data. That's a DC, thing."
Oh, I see what you're asking.
I get sick from it.
So you're highly sensitive.
Yeah.
And you're sensitive if someone has a cell phone in the room, because that signal can be measured across the room. I still measure hundreds, if not a few thousand microwatts, 6 to 10 feet away from someone's cell phone. I'm trying to help them. I'm trying to find, and they've got their cell phone on, my client, they're walking around with their cell. I say, you got to turn that thing off. I can't tell you what's going on in your room from these other sources that we're trying to turn off. But then they want me to get rid of their RF, their EMFs, and they're walking around with a cell phone. There's an incongruity there. The problem is EMFs are silent, invisible, and odorless, number one. And number two, everyone wants to stay connected. And number three, there are electrically sensitive people who are willing to put up with some symptoms to stay connected. So that's a whole nother conversation. I don't want to digress on that because we really need to wrap things up at this time. You opened up a can of worms at the very end here.
Yeah, thank you very much.
Yeah, you're welcome. Thank you, Betty.
So quick, Oram, I measured them up to 60 and 70 feet away of some.
Oh, yeah, of course.
Yeah.
Yes. Yep. Well, they go for a mile.
Yep.
Okay. All right. Now, Simona, unmute yourself and ask your question.
Can you hear me?
Yes, there you are. Yes, I
Hi,
can.
This
Go
is
ahead.
actually Valentine, but I'm on my wife's computer. So thank you, gentlemen, for the great event. I have
you.
2 quick questions. Some time ago, a few years ago, I purchased a Cornet ED88T plus meter, and it came with a little instruction sheet that allowed me to go into the settings of the meter and change the LED scale to be similar to what the Building Biology Institute recommends. I mean, what is it, no or little concern? What is it, medium concern? What is it, a high concern? And I recently sold that because the new version came up, and I actually purchased one from Rob.
Wait, you sold an ED88T plus? That is
Yes.
that is the most recent version.
Well, it's actually the G2 is the latest version, right?
Oh, they have, I'm sorry, they have a G.
A
Oh, okay.
5G, a 5G.
Yeah,
I think.
5G2, sorry.
Yeah.
Yes,
Yeah.
yes. And I don't find that instruction sheet anymore, and I would very much like to set this one up the same, because it seems to me that the way it came from the factory, you know, in the graph, it goes all the way halfway into the graph, and it still shows a green LED, which I'm not sure it's okay. I'm not disputing, I'm not saying it's something wrong with it. It's just that when I was able to change the settings on the other one, it seemed to be more congruent, what I would see on the graph and the numbers on the display and what the LED scale would show.
Right, I know I've done that in the past as well. I haven't tried it on the new model for sure. I'm not sure if did you try the same procedure that the old model had?
No, because I lost the instruction sheet that came with my old one.
Gotcha.
That's why I'm asking you, gentlemen.
Yeah, if you were to contact our support guys in the shop, just contact our support email. They'll look through the manuals and get something for you.
Okay, thank you so much.
Yeah,
And
no
the
problem.
second question is for Oram. I'm about to install solar, and I remember in a video I saw a few years ago or another training you hosted, you talked about some brands of solar inverters and charge controllers that do not cause dirty electricity. I don't remember what the brand is, but I'd very much like to buy that one.
2 primary ones and then a third one. Enphase,
Enphase.
ENPHASE are microinverters, and they're cleaner. None of these inverters are without dirty electricity. They're cleaner than the other ones that are on the
Recommended,
market.
let's say, yeah.
Well, I don't recommend a solar panel system or photovoltaic system, PV system, for anybody who's electrically hypersensitive. Don't take the chance, because too many people have called me up and said, I thought I'd be okay here, but I came into the house, we spent a half an hour walking around, we bought the house, and now I can't live here. Or my husband talked me into it, you know, we put them, and some of them are clients of mine, other people call me who I've never met, and that's what they tell me. So I have too many people who have had horror stories like that. It's too big an investment because you can't undo it easily. So, okay. So having said that, you have to, in my book, you should be non-electrically hypersensitive to even being considering this discussion. So if you're not EHS.
I am not. I'm just aware that regardless if I have symptoms or not, it's still affecting my body. So obviously I want to install the best.
Of course. Yes. Okay. So for non-EHS people and you want solar, then go with Enphase or Solar Edge. Solar Edge HD Wave is the other brand. They're a string inverter, which is on the side of the house, but they have what they call DC optimizers that go up to each panel. The whole point is that Enphase, which have the microinverters under each panel, There is no
Mhm.
string inverter on the side of the house. It comes down as 120 volts AC, although now they have a device on the side of the house. But they have low DE. Now, then you have the energy management systems with the backup batteries. And many people have that. Tesla Powerwall, Enphase, Solar Edge, and others. The Solar Edge and Enphase are DC to DC couplers. We actually had a conversation at one of our monthly meetings within our profession from the husband of one of our graduates who, and that man is, the husband is the North American Director of Technical Operations for Solar Edge. And he's working with some building biologists now, Spark and some other people in their group, to check for the dirty electricity and measure, especially their energy management systems. Those systems will see what the load is at a given time in the daytime, and they'll provide power from any of the three sources, depending on what's most efficient: the grid, the battery, or the panels.
Yep.
Okay, and they're regulating that, and so, but they keep the DE low, the dirty electricity low, because they use DC to DC couplers, and so he's aware of dirty electricity from a health standpoint because of his wife who went through our program.
Mhm.
All right,
Mhm.
Mark. Anyway, forget his last name. And then Enphase, I know from Michael Schwabe, who's measured this. He's in San Diego, highly electrically sensitive, and he's an engineer, so he has all these the oscilloscopes and test equipment, and he's measured low DE from the Enphase battery backup energy management systems. Now, besides those two brands, the other brands, they have higher DE, their electricity, and which goes away when the sun goes down for the solar panel systems. But the energy management systems stay active 24/7, and they generate DE 24/7. And there's a very popular brand, which I will leave unnamed in this public forum, but they're very high. So you just have to test. And when you get into energy management systems, then you're going into a whole nother realm where you got to be very careful. Again, nobody who's EHS should go anywhere near that stuff, in our opinion. And so that's my advice on that.
So are they so high that you can't add enough filters to filter it out?
Okay.
Or...
All right. So then I go into a home where this stuff is already in place, and I got someone who's maybe electrically sensitive or not, or maybe symptomatic or not. Now we're trying to filter it. Now you've got you can plug in Stetcher filters, you can plug in Greenway filters, or you can get the whole house dirty electricity reduction devices, SATIC, Sine Tamer. There are others out there. There's the one from Noble Electronics, Robert Palma in the Midwest. So different people in the EMF community, who operate on this more technical level, have different opinions about which of those are better, depending on their. A lot of it has to do with individual tolerance. And the best I've been able to do, at least on the meters that I use, is to lower it. Never been able to eliminate it altogether. So it's a tough thing. The question is, can you lower it with the whole house devices, which also include a setup that Dave Green in Michigan, another building biologist, has come up with at the panel, you'll have duplex outlets that go to the two legs, and you've got 4 Greenway filters there. And then they have another filter in the middle that goes hot to hot. It's a 240 thing, and you have to have a special glued in thing so nobody can plug something, because you can really damage something if you plug into it. And because it's hot to hot, it's 240. And you get a special Greenwave that can do 240, and that takes care of most of it for a fraction of the cost of the whole house units that you buy from these other companies I mentioned. There are all these options that are out there. And really, this is a discussion we should have off line, because this is a millimeter wave conference, and I don't want to, and we want to try and wrap it up. So
thank you so much for answering. I appreciate it.
You're welcome. Kay, you slipped in there at the last. Do you have a quick question? And you'll be the last person. So the person who's Kay, unless your hand is up, do you have a question? If so, you need to unmute yourself. Okay, well then I guess we're done, everyone.
I have a quick question, Oram.
Real quick, Nancy.
Does metal conduit block dirty electricity from coming into the room if you've got the wiring in metal conduit?
Technically, all right. Dirty electricity has two components, electric field and magnetic field radiating into the room. And we defined dirty electricity, and we call it microsurge electrical pollution, as the electric fields and magnetic fields from frequencies above 60 cycles per second. And the metal conduit does block the electric fields. You don't have magnetic field from 60 hertz or higher frequencies when you have balanced loads and no wiring errors between the hot and the neutral on your circuits. But the cladding has nothing to do with magnetic fields, only with electric fields. And again, this is a conversation that the only electric field that you get from dirty electricity in that case would be from the cords that you're sitting near within 6 or 8 feet of. And then the magnetic field would only be on those paths of current in your house, like on grounding paths. Beyond that, I shouldn't go because we really should wrap it up. That's sort of off topic, but I'm happy to talk to you about that.
Okay, thank you.
Thank you, Nancy. Tony and Rob, turn it back to you guys.
I'd just like to thank everybody for attending today and thank our panelists for all being here and contributing valuable information to this new field we're engulfed in, these millimeter waves. So thank you, everybody, and appreciate you guys attending. And we'll schedule this again for a month or two down the road and continue to learn and continue to get continue to find some new sources and bring them forward to you and continue the education here.